Welcome to this color science course. I'm glad you are here. What does it really mean to see color? Let's take a moment and look at this from a scientific perspective. The light we see in everyday life is called visible light. It refers to the range of wavelengths that the human eye can detect from red to violet. Light beyond red or below violet cannot be perceived by our eyes. So, what distinguishes visible light from invisible light? The colors we perceive from red to violet are determined by the wavelengths of light. You may have heard the term wavelengths before. Light is a form of electromagnetic radiation. Electromagnetic waves are waves that carry electric and magnetic properties. The distance from one crest to the next or one trough to the next is called the wavelength. Differences in wavelengths reach our eyes as differences in color. When light strikes an object, it may be reflected, absorbed, or transmitted. And the light that finally reaches our eyes is perceived as color. This is how our world becomes filled with color. Now, let's look at the wavelengths that the human eye can actually detect. Visible light is broadly divided into three categories: short, medium, and long wavelengths. The unit used is nanometers nm, which is 1/millionth of a millimeter. Approximately 380 to 500 nanometers violet to blue-green its short wavelengths. Approximately 500 to 600 nanometers blue-green to yellow-red its medium wavelengths. Approximately 600 to 780 nanometers yellow-red to red its long wavelengths. Although classifications vary slightly among textbooks, this three-part division is the general standard. Shorter wavelengths carry higher energy. For example, wavelengths shorter than 380 nanometers fall into the ultraviolet range. Ultraviolet radiation in sunlight can tan skin or degrade plastics because of its high energy. You can imagine it as tightly packed waves carry more force. Waves also have a property called amplitude, the crest height from the center line. Amplitude corresponds to the intensity of light or brightness. Short wavelengths mean high energy, while large amplitudes mean brighter, more vivid light. So, when we ask which is stronger, the answer depends on whether we mean energy or brightness. Long wavelength wave may have low energy but appear bright if its amplitude is large, while a short wavelength wave may have high energy but appear dim if its amplitude is small. The brightness on the right side of the diagram corresponds to what we actually see, but the energy on the left is only a conceptual illustration. It's not visible to the eye. And brightness here does not mean whiteness. White light is produced when many wavelengths combine. a topic we will explore in the session on the additive primaries of light. In conclusion, color is a wave. Our eyes interpret the wavelengths of that wave, and that is what we perceive as color. That's about it for this part. Thank you for watching.